Good morning to one and all linked to this live streaming. Hope all of you are doing fine and staying safe during this time of hardship. This is an initiative by the PG and Research Department of Physics, Queen Mary's College. I welcome each and every participant to this webinar on artificial intelligence in the year 2020 and its applications. Two new vibrant topics that can take you places and make you mint money if you are conversant with the nuances of the latest technology are artificial intelligence and machine learning. Queen Mary's College Physics Department has PG students doing projects in artificial intelligence under the guidance of Dr. V. Nirmala. This webinar is a milestone in the Department of Physics. We take pride in organizing this through YouTube. There has been an overture response of more than 600 participants to this webinar. Hence, we had to switch platform from Google Meet to YouTube live streaming. And for the credit, tech support by Dr. V. Nirmala is highly commendable. I take this opportunity to thank our principal in charge, Dr. Varalakshmi Anandakumar, for according me permission to do this webinar ASAP. And I must thank my pillars of support, my colleagues and faculty members of the department. Artificial intelligence, as you know, refers to the simulation of human intelligence in machines that are programmed to think and mimic human actions. It can mimic cognitive functions like learning and problem solving. I'm sure you would not have understood anything of what I said. To make the definition sound more simple and tangible, we need an expert. So we have with us a prolific speaker, an ardent researcher, humbled in words, Mr. A. Rajagopal. The speaker of today is an artificial intelligence innovator. He works as consulting partner with a leading IT firm. He is interested in advances in artificial intelligence and takes upon his stride to solve big challenges. He holds a BTech from IIT Madras and MS by Research from IISc Bengaluru. He recently did a workshop on hands-on deep learning to the big techie brains of IIT and academia. He is an artificial intelligence evangelist and consults strategic artificial intelligence transformation for global leaders. The participants for today's webinar are an avid, heterogeneous group of students, faculty members from all disciplines wanting to know from the expertise what is artificial intelligence and how and where it is applied. This webinar is an introduction to the field and will motivate you to plunge into the sea of artificial intelligence and create a career for those visionaries. So with this intro, I think it is time to hand over the session to the guest speaker, Mr. A. Rajagopal, to whom I'm indebted for his immediately accepting my request to enthuse us on this topic of artificial intelligence. And to all the participants, you can put your questions in the chat box. It will all be answered at the end of the session, and you'll have to send your feedback after the session is over so that an e-certificate will be sent to you to your registered mail IDs. So once again, a warm welcome to all of you, and I hand over the session to Mr. A. Rajagopal, the expert artificial intelligence innovator. Thank you.
Thank you, Dr. Hema, for the formal introduction. I welcome everyone to this webinar. This will be for 45 minutes. Towards the end of the session, I will try and answer your questions. So, as a question arises in your mind, please post it into the chat window in YouTube. Try and make it as easy as possible to gain understanding of some of the latest concepts in AI and some of the state-of-art techniques, including its future, its potential, and also the technology fundamentals. And towards the end, we'll also cover the applications. Once again, welcome you to this webinar. This will be for 45 minutes, and please type your questions into the chat window and we'll answer it towards the end. Now let's begin the PowerPoint presentation. My talk for today is on artificial intelligence and its application in the current decade. So what is artificial intelligence? The idea is to make a machine function like a human brain. For example, when our eye sees an object, the brain is able to identify the type of object. Similarly, we build a computer that functions like a human brain. Here is a medical image, and this is an AI program. This AI program takes this medical image as an input and identifies the type of disease. Here you see the AI is able to function like a medical radiologist. Similarly, other functions like speech recognition, forecasting the future, making decisions, identifying patterns, and finally creativity and imagination, which a human brain does, can be very well done by an artificial intelligence program. Also, the AI can function both like the left brain and the right brain. Let's explore three major applications of AI. Number one, the ability to see like a human eye, computer vision. Number two, the ability to understand speech. Number three, the ability to interpret language. AI can be used in many specialities. For example, since this is hosted by physics department, let me tell you a very good application in AI in physics. Can you use a 10x magnification microscope but see the result like a 40x magnification microscope? Yes, this is possible using a technique called generative deep learning in AI. This will be very valuable in electron microscopy. The challenge with observing biological organisms using electron microscope is that you don't want to cook the living cells with too many bombarding electrons. Hence, we limit the number of electrons by capturing at lower resolution, then use an AI program to artificially enhance the resolution of the captured image. What is the potential of AI? AI is the new electricity. We all know the invention of electricity transformed the entire world. Similarly, we are now at a time where AI has been invented, and you can imagine its impact in the next few years across civilization. The invention of steam engine transformed the agricultural era into an industrial era. Similarly, the invention of AI has a huge impact on the future of mankind. The materials in this webinar is based on these resources. You can refer to these resources for more in-depth learning. Why is AI so popular now? Most of the progress in AI is due to deep learning. Now let's understand three terms: AI, machine learning, and deep learning. AI is about making intelligent programs. Deep learning is one approach to machine learning, and this has been widely successful now. In traditional programming, a computer blindly executes the set of instructions as programmed. This is typically how you write C and Java program today. But in machine learning, a computer learns based on experiences. This is very similar to how humans learn based on experiences. Our brain and nervous system have a series of neurons connected with each other. So, if our hands touch a sharp pin, a signal is passed through a series of nerves and finally activate the muscle. Similar to this idea, a signal is passed through a series of layers of mathematical computation and finally an output comes. This is how neural networks works in deep learning. So what is the future of AI? Based on the level of intelligence, we can categorize AI into three categories: narrow intelligence, general intelligence, and super intelligence. Today's AI can do a very specific task in an excellent way, but it cannot do other tasks. For example, today's computer can play chess, but if you take the same chess program and make it to play another game, it will fail. So this is narrow intelligence specialized in one task. The next phase is general intelligence, where the same AI program can do many tasks, similar to how a human can learn to do many tasks. Now I have a question for you. You can type your answer in the chat window in YouTube. Okay, tell me which has more computing power. Is it a personal computer or a human brain? I will wait for 30 seconds. Please type in your answer in the chat window. The computing power is growing at an exponential rate. A home computer that you can buy for rupees 50,000 after 7 years will have more power than a human brain. So, both are correct answers. Yes, today the computers are much weaker than human brain, but that is going to change in another 7 to 8 years. In another 30 to 40 years, a simple computer that you can have in your pocket will have more computing power than the brain of 10 billion people put together. Exponential rise in the power of computers, when combined with artificial intelligence, will completely transform the civilization. Now I have another question for you. I will show you a short video clip for 90 seconds. I request you to watch the video and identify the problem that you want to solve using AI. So just think of one problem that you want to solve for the next 30 minutes in this session. It could be any problem that is shown in this video, or it could be another problem that you have in mind. Please type your answer after watching the video. Now we come to the most engaging part of this webinar. To make the maximum out of this webinar, I request you to take this activity-based learning exercise. Here, some of you have identified a problem statement, a problem that you want to solve. Now, going forward, let's understand few techniques in AI. And based on this technique, I want you to apply these techniques to solve your problem. Once you have some idea that comes to your mind, please type out your answers in the chat window and report your answers. Now let's understand three major paradigms in the state-of-art artificial intelligence. Our left brain, as you know, is good in identifying patterns. Our right brain is good in creative thinking. Deep learning is good in identifying patterns. The more recent generative deep learning is good in creativity. Like how human brain has evolved over centuries, there is a new system of AI that improves over time automatically. We all know of natural evolution of the species. It took almost 1 million years for the brain capacity to increase and to evolve. But it only takes a few days for the same thing to happen on the computing world. An AI program using what is known as neural architecture search would generate multiple child AI programs and then pick the best one of it. So the parent AI program will generate, for example, 3 child programs, 3 AI programs, and then check which one of them is performing best for this particular task. Here, a parent AI creates multiple types of neural networks and evaluates which one performs better. This happens over multiple generations of children, and finally the best performing generation is preserved and selected. This whole technique is called automated machine learning. This is one path that can lead to artificial general intelligence. This concept of automated machine learning is not science fiction but a reality today. Thanks to enormous compute on the cloud that is affordably available on pay-per-use basis, you can actually use this enormous computing power to run multiple AI programs and evaluate which one is best and then select that generation. To try it out today, you can log into Microsoft Azure and switch on the automated machine learning service in your Microsoft Azure AI platform. Now that we have looked at the most recent automated machine learning paradigm, let's look at the next paradigm, which is generative deep learning. This idea of generative deep learning has been quoted to be one of the most interesting ideas in the last 10 years of machine learning. And deep learning came before that, and that has been quoted to be one of the biggest leaps since the invention of computers. So what's the difference between deep learning and generative deep learning? We saw that AutoML platform outputs a neural network, a brain itself, while a generative deep learning outputs a creative thought. It could be a creative picture, a creative music, or it could be a creative video. These all could be synthesized using generative deep learning in a very creative way. So similar to how a human brain can create new ideas, the generative deep learning will create new ideas for you. And then we have a classical deep learning where output is more a scalar value. It could be used for classification and prediction of the future. You can combine deep learning and generative deep learning as well to create new paradigms. Okay, what is deep learning? Let's go deep and find out. Think of a child who is learning for the first time in her life to distinguish between apples and oranges. So how do you teach her? You show few apples and tell Papa this is apple, and then you show few oranges and tell these are oranges. And the child's brain learns to recognize the patterns automatically, and then next time she is able to figure out and distinguish between these fruits. A very similar technique is used to train a neural network. So a neural network in the case of deep learning will get trained like this. You show few photographs of apples and tell the neural network these are photographs of apples, and similarly for oranges, and then you train the model. The neural network will learn to distinguish between these two types of fruits automatically. Once the neural network gets trained, it's called a trained brain or a trained neural network model. So this trained model can be utilized now to predict or classify the future. For example, you can show a new picture of an apple. You can even show a green apple, and then this particular neural network will be able to automatically identify that, hey, looks to be an apple, though it's green in color, it should be an apple. So this kind of smartness can be brought in by a neural network. If you had tried to program this by a standard C or Java program, imagine the scenario where it was trained on red apples and you were looking for colors, but then you showed a green apple, it would not have been able to figure it out. So this kind of smartness, or also called generalization in deep learning terminology, is one of the power for deep learning. So the more the model is able to generalize, the better is the scalability of deep learning for more practical use cases. So to give you an example, if you have used a deep learning based drone in the case of a natural disasters like a cyclone, a car typically you would have trained the neural network to distinguish between a car and a bus. But then after a cyclone, few trees might have fallen on the bus and the car, and still if the drone spots the tree on top of the car, it can still tell there is a car behind the tree. So this kind of smartness or generalization power of the neural networks is very powerful idea, and this idea is very similar to how a human brain operates. Okay, now a brain learns by looking at experiences, but how does a mathematical program like a neural network is able to learn similar to a human brain? The idea is like this. A neural network consists of series of layers of mathematical computation. It has set of what's known as parameters or weights in the matrix, and these weights or parameters will get learned over a period of time. Now, for example, the first layer might learn to distinguish between these texture. The second layer might learn to distinguish based on color of the fruit. So these kind of features would be automatically picked up by the neural network and learned. Unlike humans who can learn by just few examples, a neural network typically will need a lot of examples to learn from. For example, just to distinguish between cats and dogs, you need to show the neural network at least 300 odd photos of cats and another 300 odd photos of various dogs taken at different positions, different backgrounds, different breeds, and different lighting conditions. Now, this ability of a neural network to learn the features of a dog automatically by looking at these various examples is one of the promising ideas of a neural network. Okay, you might ask, what is the practical use of deep learning? This is Arvind Eye Hospital in Madurai, who has already deployed deep learning based application to prevent blindness in India. The problem is shortage of doctors in the rural belt. Eye disease like diabetic retinopathy, if caught early, can prevent blindness. So it's very important to do an outreach program in the rural area to spot this disease at an early stage. And given the shortage of doctors, can machines help? And this is exactly where deep learning has been used. So here you see a trained nurse being able to take a photo of the eye retina using a special camera and then passes that photo to a deep learning network. So this neural network accepts an image of the eye retina like the one you see here, and then using a series of layers in the neural network analyzes that image and classifies into one of these 5 categories. A healthy eye is automatically identified, but in case the person's eye requires some treatment, it is able to spot that and then put it in the red color zone, which means immediately the person has to go for a treatment. So this ability of a neural network to be used in places where experts cannot reach is one of the most promising ideas for healthcare applications. Now let's take the same analogy in terms of coronavirus. You might have heard this new concept called COVID-TOS. Since the disease is so new, there are new symptoms that is showing up for scientists, and doctors are learning these new symptoms every day. Now, by just taking a photo of the COVID-TOS on your cell phone and then running a smart AI program, it can automatically find out if it is a normal rash or allergy or is a potential COVID-TOS. So this ability of a neural network to be used in dynamic scenarios like this, even at homes, is one of the most promising ideas. This can be run even on everyday smartphone today, even without internet connection. So this basic idea of being able to map X to Y, an input to output, through a series of mathematical computation of matrix multiplication, which are called series of neural network layers, is the essence of supervised deep learning. Now, a breakthrough happened few years back in the diabetic retinopathy case. A reputed journal in medical space, JAMA Network, identified a correlation that no doctor had identified before in the history of mankind. Here, just by looking at the retina picture, eye picture, you could identify whether the person was at risk for heart disease. So this was an interesting correlation that this neural network was able to identify. So this ability to find a magical connection between any two factors in the world is something that is possible now with deep learning. Now, just by looking at the picture of an eye, you can find out if a person has been smoking or not. You can find out the person's age just by looking at the eye picture. So this ability to connect X and Y, the age of the person with the picture of the eye retina, is something that can be figured out and learned by this neural network. So this magical connection is something that can be now applied for COVID. So given COVID is coming out with new symptoms, like for example loss of taste or smell, these symptoms could be the X and Y. These symptoms could be the X, and the Y could be whether the person is COVID positive or negative. And given COVID patients may not show any symptoms for the first 14 days, this kind of identification can do an early intervention and help the prevention of COVID. Let's see how this works from a nurse who is in the rural area. She collects the photo with the camera of the eye retina and puts her photo into the web browser, and the AI application identifies the severity of the problem and whether the patient has to be referred. Now let's look at generative deep learning. Until very recently, computers could not create new ideas. Imagination for computers was not possible until few years back. All this changed with the advent of generative deep learning. It's a slightly recent development and a more advanced deep learning network. You will build today an application with generative deep learning. Before that, let's hear a message from a special guest.
Children will be raising boys for the other children who are disadvantaged or vulnerable, and sometimes they don't get in life what they are meant to, which is their right. I think it is a great platform for all of you. You are the next generation. You are going to take over the world. And that is really important. We need to understand how you think. But also, it is a
Okay, the video was created like this. It was not a recorded video, but a video that was synthesized artificially by an AI program. So this program took in a photograph of Dr. Abdul Kalam and an audio file from Sachin Tendulkar, and then used a generative adversarial network, a new type of generative deep learning network, to synthesize this video. Now you can use the same application to actually record inspirational voice of Dr. Kalam for yourself and share it in your social media. More importantly, we will see how to build this AI app right now. Irrespective of whatever skill levels you are at, you will be able to accomplish this feat of building a very advanced generative adversarial application to do this task right now. At the end of it, you will be able to create similar such inspirational videos with photographs of your choice and audio recording of your choice. Next, we will look at autoencoder. Here, for example, in physics, you have a telescope which gives you a blurred image, but then you want to actually get a crisper image. And how do you use AI to do that? Another example is you have a black and white photo taken from your grandmother's age, but then you want to convert into color using an artificial intelligence program automatically. Let's take a look at a demo now. So if you have photos that you have in this lockdown period from your family album, please pick it out and then you can run it inside this AI program we will just show now. So this is the black and white image that we will take as an input to this AI program, and let's see how it's going to convert it. Now this is the converted color version. You see how intelligently, like a human artist, it is able to automatically add color green into the grass and the skin color and the white color for the cloths. So how intelligent is it that it is able to put a green color for the grass? Now so this program is also available for you to play with, to take your own photos from your photo album of your family and then make a color version. The healthcare industry, you get images like ultrasound image or MRI images. Ultrasound images are typically created by Doppler effect, and these images are very noisy because it's an approximation of the reflected Doppler wave. So can you use an AI program to actually make it more crisper so that the doctor can very accurately look at it and pinpoint the disease? Now, how do you create such algorithms that can do all this magic? Let's understand the science behind it. Okay, in the classical deep learning paradigm, we saw how a neural network can identify the patterns of a given input and output the classification. For example, given an apple, it will tell it is an apple 1 or orange 0. But then, given 1, can you create an apple? Can you imagine an apple automatically? Can a neural network imagine an apple automatically given 1? So this is the challenge that we have right now. Yes, it is possible. The idea is all neural networks have an understanding about the domain that it is operating. So it has learned the patterns of the domain. For example, a city versus beach classifier would have learned the patterns of a beach versus a city in terms of the blue shades, the water, the coconut tree and all that. So through a series of matrix multiplication, it is able to identify that a given photo belongs to a beach. But then if we pass the input as a beach and ask it to imagine a imaginary beach which probably doesn't exist anywhere in the earth, but then this AI is going to imagine more like a dream, and then it is going to dream up and then create this imaginative beach for you. So that's the power of such imaginative AI. Now, how does this work? So essentially, all deep learning systems are representation learning systems. Means a particular input can be re-represented in another form, and then it can again be re-represented in another form. So here we see we have a neural network that takes in the image as the input and then moves it into a latent space, which is a more compressed space, and then moves back from this latent space into a more expanded space. So here we have a convolution operation, which is essentially a special type of neural network. Again, a convolution operation with upsampling to actually move from a smaller dimension to a larger dimension. So that's the idea, where you use an encoder and a decoder together to create new imaginary articles that didn't exist. So this whole concept is called autoencoder. Some of the slides are coming from MIT Intro to Deep Learning class. And so given an input image which is 2, an autoencoder would be able to take that and then move that into a lower dimension, which essentially captures the key features of this input image, and then it might not capture the all other unimportant features, and then it is going to recreate the original input. And you will see, since it's going through some kind of a bottleneck, the unnecessary information will get lost as it passes through this network. And so here we use a technique called reconstruction loss minimization, where we actually compare the input and the output and then do a comparison of this, and then let the neural network be trained to minimize the reconstruction loss. And that's how autoencoder functions. We will use this same technique to actually minimize loss on, for example, telescope photos. So here you see a noisy input, which is a 4, which is blurred, but then the output, if you see, it's actually coming out very clear. So how did we create this model? So initially we take a very good high resolution image, manually noise it so that it looks very noisy, and then use this encoder decoder architecture and then minimize for the loss so that the output that's created is actually going to have a very high resolution. Okay, now let's switch gears and jump into applications. We have seen already the fundamentals of deep learning. Now it's time to apply it. Let's look at few problems that we can solve. One of the most promising ideas to remember is that the deep learning system can be applied to any domain. So far, we have seen lots of examples in computer vision, but the same ideas behind that can be applied for any other domain. For example, it can be applied for music, speech, language understanding, stock market forecasting, or any domain that you can think of. The underlying concepts remain the same. Now let's see if the music generated by AI is something that you want to listen. Here, attention-based model, a newer technique in deep learning, typically is used for such sequence models and for natural language understanding. This is a transformer network with encodes one set of music to another set of music. The next challenge is for COVID, how people are practicing social distancing, and is there a way to track it and educate people based on observation. Here the AI tracks if people are walking in close distances and checking for social distancing violations. The next challenge is how to use AI to help visually impaired folks. Typically, a visually impaired folk would take a photo with their smartphone, ask a question and send it to a volunteer who will look at it from the other side of the internet and type back an answer so that the person can hear it. For example, the person here takes a photo of a currency and asks what is the amount, and comes back, the volunteer comes back with the reply 10 euros. Can this whole thing be done by an AI? Yes, you can do this. Here the input is the two things, photo as well as the question, and the output is the answer, another word. So again the same trick of mapping x to y, x being the photo and the question, y being the answer. So this kind of visual questioning answering model again is feasible to be developed right now using standard supervised deep learning approaches. Next challenge, can you build a self-driving car? How easy is it? Let's find out. The same technique that we just saw all through, to be able to map an x and y, is all that is needed for you to build a self-driving car. So you actually map the X, which is the input image from your car windshield, to the decision Y that you are making, whether to apply the brake or not, and how you collect the data set. So you simply mount few sensors on your braking system and keep a camera on your windshield and simply drive the car yourself. So as you drive the car, you will be collecting photographs like this along with the decisions you made. And based on that, this AI would get trained and would learn to recognize the right set of things for it to make that decision. Same way, you would use the same technique to train the neural network to learn when to turn the steering based on different road conditions. For example, based on the road divider and the edge of the road, it has to now learn to find out when to turn the car left and right. And that's exactly how it would learn. And in the top you see it is picking up for dividers in the road to make the decision on whether to go straight or move the steering, versus the braking AI system looks for obstacles like people walking across the road so that you can apply the brake. So the architecture for this is again classical approach, where you basically have a CNN with a fully connected layer, and that's all it is to make this happen. So this is NVIDIA self-driving car P-Drive system, one of the latest self-driving car models, and the very same technique that we just saw is what is powering this particular production grade self-driving car. You just see 3 of such neural networks running in parallel, an ensemble system of 3, making a choice to make sure there is consistency among the decisions made so that you avoid accidents. As well, you are trained on a very exhaustive set of data set, different road conditions, lighting conditions, different traffic conditions, and you simply see that the decision to make and turn the steerings are all based on the same architecture that you saw. The input is the image coming in, and the output is the decision when to move the steering wheel left or right and keep it straight. So that's all is the architecture to actually power a production grade self-driving car. You need an exhaustive training set, quite a reliable architecture that you just saw, and a kind of a consistent approach with ensemble modeling so that multiple parallel systems and backup systems keep the safety of the passenger. Next challenge is safety of women while traveling alone in the late evenings. You have seen the OK Google trigger that turns on the smartphone when the word is uttered. Similarly, when a call for help or a scream is called out, the smartphone would detect that and instantly make connection with trusted contacts to ensure safety of women. We all have experienced this. A noisy telephone line when the signal is very weak. The same technique of applying super resolution for telescope image can be applied here as well for speech, where a noisy speech input can be automatically enhanced using AI, so that your phone calls can still be okay even if the signals are very weak. The next challenge is to prevent the locust from attacking the fields of agricultural lands. So the idea is to track them and proactively capture them before it attacks the agricultural lands. So how do we do this? Can we design an AI that allows us to do this? What could be the solution? The idea consists of few things. One, we basically allow an AI to learn about detecting the locust. Given these locusts are transforming pests, that means every day the locust might look different based on its life cycle. So being able to look at the locust continuously for few days inside a enclosement with a camera, and being able to use some of the models that we learned such as meta learning to automatically decipher how this transformation is happening, and then take that trained model and deploy it inside a drone that can basically track this. In addition, a GPS sensor can be stuck on by a drone or a robo that can actually stick on a GPS sensor with a tiny battery, and when the locust starts traveling across lands for long range, we use this GPS tracking with cell coverage, and for short range we use the ability of a camera of the drone to actually sense these pests from the drone camera, and thereby we track how the locusts are moving, and then we can spray the chemicals using these drones and make a smart protective mesh so that human agriculture lands can be protected and shielded from these pests. Hope this session helped you to understand the potential of AI and how the landscape around you is going to transform. Okay, thanks for joining the webinar. We have few questions coming up. Let me try and answer each of these questions. Okay, there is a first question from Naveen. What are the kind of the ML algorithms used in the industry? So in the industry, we primarily have most of the commercial activity has been around supervised learning, especially with deep learning now has become the industry ask. And to make it production grade, we also do active learning. That means in case the accuracy comes down, there's a feedback provided, and active learning takes feedback and then further trains the model and improvises it. Also, from industry perspective, Azure from Microsoft, Google Cloud AI, and Amazon Cloud. These three services, the Azure Cognitive Services API provides very developer-friendly API for us to consume and quickly get onto the AI wave. AutoML actually also democratizes machine learning to lots of developers and even citizens who may not understand really the technology behind how to create an AI algorithm. So AutoML is very powerful. It's catching up right now. It has been integrated with Google Cloud AI products like the Google Cloud AI Vision. And some of the latest algorithms are for computer vision, it is CNN and attention based models. And for NLP and speech and voice, speech and text, it is sequence models such as attention based models and transformer networks like the BERT, GPT-2, and XLNet. These things make the machines as good as human brain to understand language and even translate them. So now these language models are very powerful. It's trained on more than 1 million Wikipedia articles, and it's as good as human listening to you and then responding back. And so the ImageNet movement for NLP has come in 2019. That means all the massive breakthroughs that happen in vision is also now available in language and speech. Next question from Guru. How does the AI know which information is necessary and which is not? So if you look at it, the autoencoder model is using reconstruction laws. That means it's going to compare the output of the AI with the input and then does a subtraction, mean square error subtraction at pixel level. That means at each pixel of the image, it's going to subtract and find out whether the reproduction is correct. That means when an input is passed, how exactly is the output coming. And so that's how it's going to minimize the loss. That means the bottleneck, and then it is going through a bottleneck. So only the right information is going to go through. So all the unnecessary information it's going to remove away. So that's how it is going to automatically learn what is important to actually pass through the next layer so that the output produced is as close as possible to the original input. Okay, there's a question from Tarini that are these just ideas or all this implemented? So all the ideas that we covered here, except probably the latest, the last one, the locust, and probably the COVID ones, others are all implemented. It is one interesting thing. Thanks for asking that question. So these are all practically implemented in at least in lab level, and the user adoption is now gaining momentum. The research in AI has been so amazingly very fast that the industry is just catching up, and there's a huge, so it's like, when the electricity was invented, the bulb was invented in the lab, the other industries took time for it to catch up, but technically these are all implemented. These are all things that you can actually try out today just on your web browser with Google Colab environment or any cloud AI provider. So these are actually real ideas implemented as well, deployed in production grade. For example, self-driving cars. For example, speech that you can speak into your cell phone today. These are all examples of really implemented use cases. Music generation is again one. For some of the nanoscale biology related looking at nanoscale objects from an electron microscope, this is again implemented. So some of these advanced technologies have been very well implemented. What is really coming up in terms of adoption is on the generative deep learning because of the creativity. That's one place where the industry adoption is just coming in because the technology itself came in almost like 4 years back. So that's the place where adoption is coming in very right now. Otherwise, these are all practical ideas, and the space itself is so amazingly evolving so fast. Question from Aparna. Um, where is the input and where is the output displayed? So AI is one technology that can be deployed on any kind of device. It can be deployed on a server, on a cloud. It can be deployed on your smartphone that you already have in your pocket. That you already have at even 5,000 rupees smartphones are capable to do AI with something called TensorFlow Lite. So if it is a smartphone deployment, you can actually have the input coming in through whatever input that, like a camera or a speech microphone or a text that you type in, like a predictive keyboard, and the output can be picked up by a program and appropriately shown to the user. So on the AI, on top of the AI model, you will have a kind of a wrapper functionality, more from a make it user friendly and intuitive for the user to learn. For the cloud side, you will have the model running on the cloud, and then you will have probably an XML web service call sending all the traffic into that AI model, and then the AI, once it infers, once it predicts, you will send back through the XML web service, and then the other apps can consume on top of it. Question from Pranav. What is the possibility for COVID implementation? So COVID right now, the X-ray of patients of COVID can be actually picked up, and there are already research papers published in medRxiv and bioRxiv websites. And given this is relatively new, the amount of data set available for COVID detection with the X-ray is relatively small, so it's not gone into, it's yet to go into um, real production use case. But once the data set comes, it can actually, it's likely to get into production. It depends really upon the kind of data that is available, the community is able to collect and provide and label and train the model. So that's data set dependent. From a COVID perspective, there's a lot of momentum established. For example, you can actually join the alliance from XPRIZE, and you can also participate in the Kaggle CORD contests, which are all actually looking at, they have already published huge data set on NLP, for example, natural language processing, to collect all the publications that is coming in related to COVID and provide you a single place of one place to actually do natural language processing to understand what are the key trends that's coming up in the COVID space. Uh, Again, question from Pranav, what's the kind of data that is we are running now at 12 o'clock? Um, what are the kind of data that is available? What is the amount of data that's required for you to train the model? The more the data that's available, the better is the training, the better is the accuracy. Um, can a question from Manju, can AI be used to predict air pollution? Certainly, yes. Saravana Kumar, can we use AI in stock market? It is already been used. Vigneshwari, can AI be used for better treatment of mentally challenged people? Yes, definitely. Both for uh, prediction of um problems early on before the actual symptoms show up you can actually do early prediction by brain scans, and also for people with cognitive disabilities, so for example vision impairment and certain impairments, the ability of AI to actually supplement them and help them is very real now. So that's a very big opportunity. In fact, Microsoft runs are giving away grant prizes right now to folks who are submitting applications for research. You can actually very well apply for the Microsoft Accessibility Research Grant and really do practical use cases. Um, okay. We are now running at 12:02. Just another couple of minutes winding up. Question from Jasmine. How can AI revolutionize education? What kind of effort should be taken up? Can you tell about the AI sites from Tarni? In the education space, if you're looking at learning, or if you're looking at from a student's education point of view, it's now becoming, I think, one of the core subjects. AI is something that, given the kind of power behind it, it's going to be one of the core subjects. And in terms of job opportunities, is really one field where not much people is available for industry to hire. So this is something that certainly something that you can invest really. In terms of use for application in education sector itself, it can be very effectively used for personalized e-learning, where you actually can have an AI coach the student at their level. For example, it can continuously be motivating the student at their grade level, and it can also try to understand where the student is interested and where the student is more weaker. So in that kind of analysis also it can be do. It can be a very excellent trusted coach and a facilitator that can augment the teacher. Um, and there's lots of powerful ideas in education that can be developed. Bill Gates has a very nice vision. Probably you can look at Melinda and Bill Gates Foundation for their work in AI in education. Um, can you tell about the AI sites? Yes, I'll just come and show you quickly about that. Um, Let me just show you the kind of sites that you can look at for you to deep dive. So these are the sites that you can look at. Um, MIT Intro to Deep Learning, yes, 191 class is amazingly good. 6 hours of plain good, very fantastic lectures, and they cover it right now. 2020 class update is also there. So these are all videos that is available on all the AI topics. Amazing website for deeper work. You can look at Stanford for the next level in computer vision CS231, and for NLP CS239 if I remember right, and there is NPTEL course from IITM as well. And you need to actually look at these three other websites, which is amazingly good. The book by Cholet is really fantastic book, Deep Learning with Python by Cholet. You will find other authors, but this is the one that you need to pick up. This straight away comes from the author of Keras, whose mission was to make AI accessible, and he has completely come out with a library called Keras, which is on top of TensorFlow, which now is the official Google standard for TensorFlow 2.0, which is the latest one, and Google simplified all their TensorFlow 1.0 implementation by adopting Keras framework in 2.0. So now this is the friendliest way to move ahead to code actually deep learning programs. So Keras.io, and that book is Deep Learning by Cholet Francois. Second, very, very useful website. You can straight away register today. Really, I encourage everyone who want to get a job to get into deeplearning.ai, pick up the five courses. He is Professor Andrew Ng from Stanford. He has published five courses. In fact, he has left his position as a CEO. I mean, chief technology scientist at both the Chinese giant Baidu as well as Google Brain, and he has been now contributing into educating a lot of folks on deep learning. So that is his course. Please look at deeplearning.ai and you will find amazing content and energy coming in that side. If you're slightly on the research track, go ahead, definitely look at Jeremy's Fast AI, amazing PyTorch implementation, and also look at Udacity's paid courses. But um, this book and Deep Learning AI and Fast AI. So these are all amazing places for you to straight away listen from the experts. And this is something that I want to really encourage. This is one field where a lot of noise is coming in terms of news, but this is something that is also very, very real. It is like the new electricity that just got invented. So you will definitely hear a lot of buzz over the next decade. It's one place that's transforming the entire landscape of multiple industries. Um, I really encourage you to go deep into this, and definitely there is a fantastic career for anyone who just invests their 3 months of time in any of these courses that's online. Really fantastic, fabulous career ahead, and not just that, you can also take up projects that and do research as well. In addition to some of the AI for SDGs, the Sustainable Development Goals as well, which are basically things like, for example, solving problems like COVID, agriculture, in these kind of areas is really also possible for individuals. At individual capacity, you can contribute and make a global impact, and that is certainly the potential for some of these powerful technologies. Um, and then one last question. Dr. Rabi, locust may change from place to place when they breed and migrate. How to overcome this issue? So the challenge with locust is actually the color and shape of the pest changes over time. So we need to have a model that is probably going to look at this change and being able to adapt to this change. And so a meta learning model would be certainly useful. And since they're migrating from hundreds of kilometers, probably you want to not just do a drone level, but also stick on a GPS kind of a thing, as well as do some kind of satellite based approaches. So I think that's all we have time. We are already at 12:10. Let me thank everyone who has been interactive and has joined in. It's a great privilege for me to come and interact with you in this hour of great difficulty outside. And thanks for logging in into the webinar. And stay safe. And I really thank also QMC Queen Mary's College for hosting this webinar at this time. And I encourage everyone to look at AI as a big opportunity for transformation when they get the free time. Some of the questions I'll try and answer it later on in the chat window, as well as the source code. If you are interested into going into source code, I'll also post it probably in a couple of days into the website. Now I'll hand it over to Dr. Hema from QMC. And meanwhile, I think there is a feedback form that has come in. Please go ahead and put your feedback for this e-certificate. Let me hand it over to Dr. Hema, and thanks again for dialing in.
Good afternoon. It was indeed an awe-inspiring lecture on artificial intelligence by Mr. A. Rajagopal. His expertise is evident from the exuberant talk in chaste English. My sincere thanks to you, sir. The innumerable questions posted by the audience speaks the reach of the webinar. I am pretty sure it would have created a spark in several of the student participants to learn furthermore and make artificial intelligence and machine learning a career. I wish to place on record my fervent thanks to all my colleagues in the Department of Physics, Queen Mary's College. I wish to mention a few significant contributions in making this event a success. Mrs. J. Srividya, Dr. S. Sarojini, Dr. S. Mahalakshmi, and Dr. B. Anita, and of course all other faculty members for their technical support and reaching to a wide audience. My sincere thanks to Dr. R. Rajkumari for preparing the colorful webinar brochure. My thanks to all the participants for making this event a grand success. It is me, Dr. Hemamali Rajagopal, Head of Physics, Queen Mary's College, signing off till we meet yet again in another forum. Thank you.